before we get into some of the more complicated polynomial division problems, I wanted to talk about a few facts using just whole numbers. The big idea in this section is that we're going to be given specific factors or possibly zeros of a polynomial and then being asked to divide and then if possible find remaining factors or zero. In this particular example, I'd like to think about a simple problem just using the fact that 4 is a factor of 20 to find another factor of 20. So if I have been given the fact that 4 is a factor, then I know if I long divide 20 by 4, I'm guaranteed to find another factor. So in this case, we know that 4 goes into 20 5 times, and then when we multiply 5 times 4, we get 20, and we have a remainder of 0. So I can always long divide, given one factor, to find another. Okay, so here I'd be able to say, so 5 is also a factor of 20. In this section, we're going to use long division and also what we call synthetic division. When we write our answers down, it's important that we write them in a particular form. I will show you an example of this form, but once again use whole numbers, and then later we'll do this with more complicated polynomials. So this example says use long division to divide 17 by 3. So we'd say 3 goes into 17 5 times. 5 times 3 is 15. 17 minus 15 is 2. Remember from a very long time ago, we call the number that we're dividing by the divisor. In this case, we'll say d of x. The value that we get on the top is called the quotient. We will call that q of x. And then the value you get on the bottom is your remainder. In this case, we will think of 17, which was our original number, as the original function, f of x. And so the way we will write our answers in these particular kind of problems is we would say f of x equals d of x times q of x plus r of x. Let's do that with the specific numbers that I have from this problem, and you can see how it works. Our f of x function would be 17. The divisor was 3. The quotient that I got was 5. And then the remainder was 2. And we can see that this is a true statement. Another way to write 17 is by writing 3 times 5, which is 15, and then adding 2. As another example, it's asking me here to long divide 30 by 5. So if I do that, I know 5 goes into 30 6 times. 6 times 5 is 30. The remainder is 0. What happens when we have a remainder 0? If the remainder is 0, I'm just going to abbreviate that r of x is 0, then whatever value I got on the top, the quotient, is a factor of the original number, 30. And we'll say f of x, we've said that the thing underneath is normally our original function. And so on here, this is a very important statement and something that we will use a lot. We can say two things about this. We can say if the remainder is 0, then the quotient is for sure going to be a factor. Also, we can say that when you multiply your 6 and your 5, they're going to multiply evenly back to your original function or back to the 30.